Hello, welcome. In this video, we will try to understand how UGV will find its path. So first, we will set up the environment. This environment will help us to understand for a navigation of UGV. So let's start. So suppose we have this environment. You can see there are basically 12 boxes. So there is 4 columns and 3 rows. And in this, we are going to put a UGV inside this unmanned ground vehicle. And unmanned ground vehicle will try to move across these blocks. And then afterwards, we will try to make the UGV automated using artificial intelligence to move inside this box. So your UGV is ready to move, and it can move on this box, it may move on this box, it may move on this box, it can move on a different box like this. Now we will make an environment difficult for a UGV to move. So first what we will do, we will put some obstacle. So when you put an obstacle like this, the UGV is not allowed to move on a left side of your screen. Okay, so left side movement is not allowed. The downside movement is allowed for a UGV. Suppose we put a 2 obstacle like this, then right side of your screen and the top side of your screen, this movement is allowed. But the downside of your screen and the left side of your screen, the movement by the UGV is not allowed. Great. So what next now? Suppose we put this kind of obstacle. So right and left movement of the UGV is not allowed, but up and down movement by the UGV is allowed. Great. So let's make all the obstacle together and make one environment. Okay, you can see if you're in a particular block, the movement which is not allowed. Okay, so suppose if the UGV is on, let me take the markdown. If the UGV is on this side, this movement, up movement, and the right side movement is not allowed. If the UGV is suppose over here, it is allowed to move on these 2 blocks, on this side, on this side. There's no obstacle over here. Okay, if the UGV is here, it is allowed to move on this side, free movement, this side. Okay, but if the UGV is here, not allowed to movement on this side, on this side. Great. So let's see on what movements are not allowed. So the cross mark movements by the UGV is not allowed in the environment. So UGV, if in a particular location, we need to think that this kind of a movement is not allowed by the UGV. Okay. So your environment is set, your UGV is ready, and now we will try to automate it. Okay. So now before starting the automation, we need to decide the target location. So from any location, we are thinking right now that it should reach to this target location. So wherever your UGV is, it must reach to this target location. Okay, great. So now what we are going to do? We are going to set up our environment like this. Okay, now this is a perfect environment for UGV. You can see what a transformation of the environment. Okay, so the moment you can check out how the UGV can move inside this. So it is very difficult at the initial stage by glancing the screen that what should be the movement of the UGV. So it's better we should name it like this. So what we are going to do, we are going to give the name to the environment. You can see what a transformation of the environment for UGV. So this was the original one. We have transformed into this kind of a stuff, and now we have named it like this. Okay. So what is the meaning of that? Meaning is like this. So A and B is not connected. So if the UGV is at A, it is not allowed to go to the B directly. It has to go through this space. Okay. If your UGV is G location, it may take the path like this. It may go like this. Okay, it may go like this, or it may go like this. so that you can decide which part to follow. You can just tell your UGV if you just need to choose which part is better for your UGV. Okay, by giving certain conditions. If this is a location, then it may go from the different place. Okay, so there are two ways you can go from here. The first way is directly you can take this path. Okay, or the second way is you can take this long part from here to directly over here. Okay, great. So now this is very much clear that how we can take a different path in the UGV. Okay, so first part is very much clear that how to go from one any place to the target location. So now first we will decide that how to fill this matrix. Now what is this matrix is all about? You can see there are basically 12 12 components over here. There are column as a 12, and there are row 12 and there are column 12. Okay, there are 12 rows and 12 columns. How we actually make this? So this is basically from this. So you can see A to L is basically 12. So this is 1, this is 12. Okay, so we can name it as 0 to 11 also. It's completely fine if we can give to 0 to 11. That would be a better idea. 0 to 11 is basically the number. So A is considered to be a 0 and L is considered to be as 11th location. That would be a better idea. Great. Okay. So now first, what what we are going to do, we are just going to go from we are just going to fill this matrix, 12 by 12 matrix. So we are going to start from A, and suppose we want to go to B. That is not possible. So A and B connection is not there, but there's a connection between A and D for sure. So we are going to feed A and D as one. Okay, A and D is one. The rest of the things are zero. Why it is zero? Because they are not connected. A is not connected to anything directly, but A is only connected to D directly. Great. Now the next part is suppose this one. Okay, in this, let's take the example of a B. B is directly connected to only C. So B is directly connected to only C. The rest of the part is zero. You can see. Okay. Now let's take one more example. The C is connected to B. The C is connected to F. Okay, C is connected to B and C is also connected to F. Great. Okay, let's take one more example, then it will be very much clear to us. Let's take a random example, G. So G is connected to D. You can see D, and G is also connected to H. Okay, so these two are one. So let's go inside that and see. Yes, G is connected to D. Yes, G is connected to H. Let's take one more example, then it will be fine, 100% fine with us. I is connected to F. Okay, and I is connected to L. I is also connected to L. So I is connected to F. I is connected to L. Yes, very true. Okay, so this way you have to fill this 12 by 12 matrix. So now going further, yes, in this we need to decide a very important part, and that is destination. So in this destination we choose as B, and B is our target location. So every time we need to reach B only. You can decide in a further part from any location to any location, but the initial stage we are thinking that we want to reach to B location at any cost. Okay, so B we want to reach to the B location, and that is basically the destination location. Okay, so that has a priority number one. Next priority you can decide as per your requirement, but I'm just thinking that my max priority is B. So what I'm going to do, I'm just going to put a value over here, and that is 1000. So you will be surprising why to put this 1000 value. You can put any value which is greater than 0 and 1. There are two combinations, 0 and 1. If there's a connection, then there is a 1. Like A and D is connected, so there is a one I kept. Okay, and A is not connected to the other things, so everywhere there is a zero. Okay, zeros and zeros. Okay, now I have choose that B is basically the target location. So B to B is basically we have to take as maximum value. It may be 1000, 200, 300, anything value you can take. It should be greater than 0 and 1. So when you take a value, higher value, what would be the advantage? The advantage is this way. So you will get a lot of variety for this. So we are going to take a help of a Q learning. So this A all 1 will be replaced by some method. This all 1 will be replaced by with some value. So when you take a value between 0 to 1000, a lot of different value combination we are going to get for the replacement of this 1. That's why this 1000 value has been kept. I hope this is clear why this 1000 value has been kept over here. So I'm going to show you the code also for this, what code is been required uh, for writing this much. So we have basically set up the environment and we'll try to see what would be the code for this. So here I am with the code. Okay. So this code is I have written in the Google Colab. You can use any ideally to write your code. This is the IPython file. Okay. So I'm going to take a help of a library called as a NumPy. Okay, let me just enhance this. So this NumPy is basically the library used for making the data in form of array. So that's why this NumPy library we are going to use. Okay, this part of a code I will explain later because this is basically the Q learning. So the important part is I am basically going to import NumPy as NP. Now the location. So A, B, C, D is not understood by the Python. So this was what our environment. We're going to replace this with basically location to state. Now what is the meaning of location to state? So wherever there is a A, I'm going to replace it with 0. Wherever there is a B, I'm going to replace it with 1. C to 2, D to 3, and L to 11. Okay, so this is basically called as a location to state. Now this was a matrix which we have created for us, and this matrix is 12 by 12 matrix. One means the B and C is connected. Why this 1000? I already told you the reason for that. Okay, because the B is our priority. We want to reach to the B location at any cost. Okay, so how the matrix has been created? You can see 0, 0, 0, 1, and all rest are zeros. So 0, 0, 0, 1, and all rest are zeros. Okay, 0, 1001, 0, and all values. 0, 1001, and all zeros values. So just I copied this into this array. So I'm going to create an array using basically the NumPy. Great. So this NumPy array, we will take it further to actually design our AI code for AI artificial intelligence for unmanned ground vehicle using Q learning. But before that, we need to make an array, and this array is ready for you. Okay. So whatever presentation I have shown you, I have basically converted back this into basically we can say into the code. So I hope this part one is clear to you. Stay tuned. Thank you very much.